Hi guys, it's Genius Maths over here. Today we'll be learning about trigonometry. So how to find the length of a side or the angle in a right angle triangle. So as you can see the picture at the top left, you have three formulas that you need to know. And I've written them at the top as well. So the first formula is a sine formula, otherwise known as SOH, which is I'll tell you a bit about. It might be confusing SOHCAHTOA, but I'll go into that. So the sine rule, essentially, it consists of the opposite and the hypotenuse. So if you have an angle, whether you're finding an angle or you're given an angle, the side opposite the angle is known as the opposite. And the hypotenuse is simply the longest side in a triangle. So the longest side in a triangle. Um, so yeah. Then the cosine rule consists of the adjacent and hypotenuse. So here's where I understand it could be a bit confusing as to what adjacent is, and how you identify it in a triangle. So essentially, how I like to, or how I find it easier to understand what the adjacent is by process of elimination, because you can define the opposite and hypotenuse. So the opposite is simply the side opposite the angle that you're given or looking for. So, and then the hypotenuse is the longer side. So the only side not that we haven't used is the adjacent, and that would be the adjacent, the side that is not used, if that makes sense. Hopefully it does, but yeah. Um, so yeah, it's just the opposite, the hypotenuse. That means the only side that's missing, it's got to be the adjacent. So yeah, the cosine rule, it's when you're given the adjacent and the hypotenuse. And finally, the tangent rule is when you have the opposite and the adjacent. So the sine rule is simply opposite over hypotenuse, cosine rule is adjacent over hypotenuse, and tangent is the opposite over adjacent. A simple way to remember this is like just remember the three terms at the bottom: so, ka, and toa. So I know it might sound weird to say, but it does help you. It helped me certainly. But yeah, I think it's a good way to remember the three formulas because if you look for the sine rule, it tells you O and H, so you know opposite over hypotenuse. Ka, well, it's A over H, adjacent over hypotenuse, and toa, it's O over A, which is opposite over adjacent. So now we'll get into some examples of how to use them in an exam style question. So over here we have an exam style question. So question number one. So we have a submarine S dives for 300 meters at an angle of 24 degrees to the surface. Calculate the depth of the submarine as shown in the diagram. So we have that diagram. Now I'll just copy that diagram just to make things clear. So we have the right one there. So this side is 300 meters. We know this is the side we're looking for. The length of that side, and we're given that is 24 degrees. So I'm going to label in red what we have, so it's clear to see. So the side opposite the angle that we're given is the opposite, meaning that D, the length of that side that we're looking for, trying to find out, is the opposite, and we're given the hypotenuse, which is the longest side in the triangle, which is here. So what do we have? O and H. So what formula consists of O and H? Well, that's the sine rule, opposite over hypotenuse. So what we can say is sine 24 is equal to the opposite, which in this case is D, and 300 meters is the hypotenuse. How do you find out D? Well, it's simple rearranging. D is equal to sine 24 multiplied by 300, and that you type that in your calculator. These type of questions will generally be in a calculator paper, so that gives you to the nearest whole number 122 meters. So the depth S is 122 meters. All right, so on to question number 2. Calculate the height h meters of the trapezium shown below. So I'll draw that out just to make it a bit easier. Right there, we know that there is 17 meters. We know that there is 11 meters. That's h. That's 49 degrees. And we want to find h. And that there is a right angle triangle. I'm going to draw that right angle triangle just so it's easy to see. So now, what we know is the bottom length of the trapezium is 17 and the top length is 11. So that means that triangle, the base is simply 17 minus 11, which is 6. We know that 6 meters. This height, this side here is h, and we don't know the hypotenuse, but we do know that, which is 49 degrees. So yeah, so what we want to find is simply h. So we know that what do we have? What do we have? We have that side opposite angle, which is O, which is labeled as h. And we don't have that hypotenuse, but we do have the adjacent. So we have O and A. So what formula consists of O and A? Well, that's the tangent formula, opposite over adjacent, TOA, otherwise known as TOA. So what we can say here is tan 49 is equal to the opposite, which is h, labeled as h in this case, and the adjacent, which is 6. Simple rearranging, h equals tan 49 multiplied by 6, and put that in a calculator, and get nearest to the nearest whole number, you get 7 meters. Therefore, h is equal to 7 meters. Okay, so on to question number 3. Kate is flying a kite. She lets out 32 meters of string, pulled tight at 65 degrees to the ground. Calculate the height of the kite as shown in the diagram. So I'll draw that diagram out just so it's easier to see. We have something that looks a bit like that. You know that's 65 degrees. This here is 32, and that there is the height we're looking for. So I'm going to label what we're given. So we know the side opposite the angle, which is labeled as h, the height that we're trying to find there. So that's opposite, and we're given the length of the longest side of the triangle, which is known as the hypotenuse. So what are we given? O and h. What formula consists of O and h? Well, it's the sine opposite over hypotenuse. So we can say sine 65 is equal to opposite, which is h, and the hypotenuse, which is 32. A simple rearranging, h is equal to sine 65 multiplied by 32, and stick that in a calculator, and to the nearest whole number, 29 meters. So the height that we're looking for is 29 meters. On to question number 4. So a ladder which is 5.2 meters long is placed against a wall. The foot of the ladder is 1.6 meters from the wall. The size of the angle between the ladder and the ground is x degrees. Calculate x. So I'll draw that triangle out just to make it a bit clear. Sorry, that's not right. It's like that. That's the right angle there. We know that that's 1.6 meters. We know that's 5.2 meters. We know that that's x degrees. We want to find now the angle. We want to find that angle. So this is a bit different to the questions we've been looking at, because other questions we've been finding the length of a side or the height. In this case, we're trying to find the angle. So again, label what we have. We don't have the opposite this time, but what we do have is the hypotenuse, which is the longer side, and therefore we have the adjacent. So what formula consists of a and h? Well, that's the cosine formula, which is simply adjacent over hypotenuse, otherwise known as ka. So now we can get on to finding what x is. So we can say cos of x is equal to 1.6, which is a, and h, which is 5.2. Now, how do you find, this is something you probably will need to know. You will need to know how to find inverse of an angle. So if you're given cos of something, well, simply to find x, that's just the cosine inverse of 1.6 over 5.2. And you stick that in a calculator, and you will get to the nearest degree, you get 72 degrees. So yeah, x is equal to 72. Okay, on to question, whoops, sorry about that. On to question number 5. Question number 5. Okay, so 3 rows from a right angle triangle are shown in the diagram. The main street is 200 meters long, the park road is 170 meters long, and the angle between the West Gate and Park Road is 90 degrees. The size of the angle between the main street and the Park Road is x degrees. Calculate x, give your answer to 1 decimal place. So we can draw the triangle out that we have, which is something like that. So I'll make that a bit straight actually. There we go. That is the right angle. We know that here is 200 meters, And you know that that's 170 meters, and this here is x degrees. So start labeling what we have. Well, we don't have the side opposite the angle, but we do have the hypotenuse, which is the longer side, and we do have the adjacent in this case. Probably make it a bit. So yeah, now we can start finding out what x is. So what formula consists of a and h? That will be the cosine rule, which is adjacent over hypotenuse, otherwise known as K, which is a way to remember it, a over h. So we know cos of x is equal to a, which in this case is 170, and h, which is 200. X is equal to the inverse cos of 170 over 200, and stick that in a calculator, and you get. So this is asking give your answer to one decimal place. So for one decimal place you get 31.8 degrees. X is equal to 31.8 degrees. Last but not least, we have question number 6. ABCD is a rhombus. Side AB is 7 centimeters, and diagonal AC is 12 centimeters. As shown, calculate the size of the shaded angle BAD. Okay, so I'm gonna draw a mini right angle, not a mini, but I'm gonna draw the right angle triangle that we can take from this rhombus. So that's what we're taking, right? But just bear in mind when it comes to actually finding that angle, well, okay, well, I'll go through it. We know over here that's 7 centimeters. Now we know from A to C is 12 centimeters, but this is just half of that. The base of that triangle is just half of that. So it'll be 6 centimeters. And the angle that we're trying to look for in this case is this angle here. I'll just call that x. So when we find x, well that's not really answering the question, because the question says calculate the size of the shaded angle BAD. So we find what x is. Well, that's only half of the answer to the. That's only half of the answer. We need to, when we get a final answer to what x is, we need to double that value to find the size of the shaded angle, because this angle in this triangle is just half of that angle. So we start labeling what we have. Well, we don't have the opposite, but we do have the hypotenuse, and we do have the adjacent. So what we can say, well, what formula consists of a and h? Well, K, which is the cosine formula, adjacent over hypotenuse. So we have cos of x is equal to a, in this case 6, and h 7. How do we find what x is? Well, cosine inverse cos of 6 over 7, which gives you 31, 31 degrees to the nearest degree. However, you get whatever answer you get in your calculator, just keep that in your calculator, because, well, we don't want to take off that. We don't want to start rounding off now, because we want to round off our final answer and our final answer. is simply, well, whatever that is, multiplied by 2, which gives 62 degrees to the nearest degree. So angle BAD is equal to 62 degrees to the nearest degree. And that's it for today. So we went through 6 exam style questions based on trigonometry. So some of them were to find the length of a side, and some of them were to find the angle when given two sides. Um, so yeah, I hope you learned today. Hope you found this lesson useful. Um, I'll leave a link in the description as to where you can find more past paper questions like these, and then you can practice them on your own. Um, and they will have solutions to them, so you can mark them yourselves. Yeah, that will be linked in the description below. And yeah, just like and subscribe. And thank you for listening today.